Now, building something and reproducing something, easy. Any chimp can do it. Explaining something is where wisdom and true intellect comes into play. See, anybody can observe phenomena, like the idiot Einstein. He won a Nobel Prize for the photoelectric effect. By the way, this device, I'm going to tell you how it works in a second, works the exact same way the photoelectric effect works, as incorrectly explained by Einstein. Well, Einstein won a Nobel Prize. Yeah, you know what that means? That means one idiot, moron, tried to explain something, and that explanation was accepted by a lot of other people who patted him on the back and gave him a Nobel Prize for something that he didn't deserve. Correct observations which are reproducible does not have any bearing on the explanation for that phenomena. This
All
is a
right, peace. What it is? Today we gonna go part two of my last video. I left off of this book right here, Future Science. And this book, he basically killing these quantum physicists and they whole science because
And Mother Nature, she's a really, really simple gal. Okay, she's not an insane hooker on crack, as quantum mechanics would have you believe.
the science is equivalent to World of Warcraft. You know, World of Warcraft. I believe that's that game where people can be like dressed up as characters and shit. And it's like a whole world, and they got like a whole thing. You can go in there and be a whole different person, and you gotta have levels and shit. And it's just a whole different realm of science. You understand what I'm saying? And it's all created and it's all made up, but it makes sense all in its own realm. You see, that's essentially what modern physics is. It's theories upon theories upon theories of descriptions of observations.
Correct observations which are reproducible does not have any bearing on the explanation for that phenomena.
You see what I'm saying? So they created a a science, a knowledge base off of theories. That's no different from a video game. There's thousands there's things that happen in video games. None of it's real, but it's real within the game in itself. You see what I'm saying? Because in the game is set up on a foundation of programming and blah 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 blah. Their foundation is Newton and gravity. This book clearly explains how and what gravity is, what we call gravity. And essentially, it's just an equation for an observation.
Correct observations which are reproducible does not have any bearing on the explanation for that phenomena.
Something fell, and a guy drew up an equation that describes the thing falling. And they've based their whole science structure off of that foundation, off of a formula that describes something that they seen.
This is a huge error in science. Huge error in science. Academic hubris is so. Where's your PhD at? Your PhD. You're saying you know more than people have a PhD. You know what a PhD in peer-reviewed means? PhD in peer-reviewed means that you kiss a bunch of assholes of people above you, you agree with their crap, and all those people did was agree with crap before them. It is a giant circle jerk of stupidity, ignorance, and hubris. 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 Academic hubris is the gigantic, disgusting cancer that sits inside the brains and the eyeballs of modern science. All these people do is parrot one idiot before them. And no invention, no creativity, nothing is discovered new unless you start to think outside of the box and you stop kissing the ass of the people before you that didn't know anything and the people
You
before them.
see, do you understand the problem with this? You'll never understand how anything works with this. All you gonna understand is a whole bunch of numbers that give you a whole bunch of theories. So what can you do? You have to accept the theories as being 100% correct. Because if you don't do that, then you can't go any further with any more experiments. Because you have nothing, no leg to stand on. So you have to say, well, this is real. You have to say gravity is real, right? So you'll do some experiments. You'll find some contradictory information, like the Michelson-Morley experiments. Then you have to create a special relativity to make it make sense.
There's no such thing as a speed of light. It is a rate of induction. The maximum rate of transverse field phenomena through a medium. That medium, of course, being the ether. There's no such thing as warp space-time. Einstein was incorrect on this. There is no premise to back this up. It's dielectric acceleration. That which we call gravity is dielectric acceleration.
You see? So this is what's been going on. And then theories upon theories upon theories. And then this is what they call quantum physics. So watch her. We're going to go. Let me just read this real quick so you understand. It is hard to believe that since then, for more than 350 years, still no one understands what gravity is, or what causes it, or why we have to multiply the wrong answer by G to get the right one. By 666. Right? And to this day, no one understands what G is or even where it comes from. This is how sophisticated we are. No one understands why objects fall to the ground. So what you call gravity is just an equation. That's it. Of an observation. You know? Doesn't explain to you how what it is, how it works, why it works, what's it for. And I'm going to show you with these two videos how how their logic doesn't work by itself. Even in the World of Warcraft game or whatever, or in Grand Theft Auto or whatever, you know what I'm saying? Whatever realm where you play them games, they have set rules and things. Things work because this is what it is. But I'm going to show you how this quantum physics doesn't work at the fundamental basis. So nothing else of it makes any sense. Okay, so these are the 12 great mysteries of physics. According to him. See, if you Google that, you're going to find 10 great mysteries. You're going to find 18 great mysteries. Look at this. One thing is, what is dark energy? Something they made up. It's a theory. What is dark matter? Something they made up. A theory. What is the arrow of time? I already showed you time ain't real. All their parallel universes. They have no idea. Why is there more matter than antimatter? They have no idea. No idea. The collapse of a wave function. This is the it's a wave when no one's looking at it, and it turns into a particle when someone is observing it. That's the you are God, because you are putting your energy towards the static electromagnetic realm, and you're creating a particle. Okay, that's what that's about. The collapsing of a quantum wave. And then string theory, another theory. All of these are theories. Look, dark energy, don't know what it is. Dark matter, don't know what it is. Is it a wave or a particle? What I was just talking about, time. See, so are we living a hologram? So you understand, these are real questions that they have no idea. And all this stuff that they claim they know is calculations. Calculations that they've created within their mythology. Okay, so what stops the positive charges, the protons, in the middle of the atom from stringing apart? I'm going to show you a video of what they claim does. And matter of fact, before I even go into any more of these, let me just stop right here. And we'll do these on the rest of the videos. But check it out. What stamps the positive charge in the proton? First, get an understanding of what they call real in science. Okay? And what they call exist. I showed this in the last video, but she go a bit more in on this one, so watch.
Today I want to talk about what scientists mean when they say that something exists. Look, I'm a scientist. Scientists don't deal with beliefs. They deal with data and hypotheses. Science is about knowledge and facts. It's not about beliefs. And what I know is that Einstein's theory of general relativity is a mathematical framework from which we can derive predictions that are in excellent agreement with observation.
So you heard her. Einstein's theory is a math problem that they use to describe what they see. Okay? It's not an explanation for what's going on. You understand? Watch, keep going.
We have given names to the mathematical structures in this theory. One of them is called gravitational waves.
Okay, so you heard of gravitational waves are a math problem. Nothing but a math problem. You see?
Another one is called black holes. These are the mathematical structures from which we can calculate the observational consequences that have now been measured by the LIGO and Virgo gravitational wave interferometers.
So you see, these things that we call real are simply equations that fit theories that are descriptions of observations. But watch, she's going to explain to you the logic that they follow. Peep.
When we say that these experiments measured gravitational waves emitted by a black hole merger, we really mean that specific equations led to correct predictions. We really mean that specific equations led to correct predictions. It is a similar story for the Higgs boson and for quarks. The Higgs boson and quarks are names that we have given to mathematical structures.
Alright, now keep this in mind for when I go to the next video, because she just told you quarks ain't nothing but a mathematical equation. It's not real. But remember, quarks supposed to make up protons. Okay? So peep.
In this case, the structures are part of what is called the standard model of particle physics. We use this mathematics to make predictions. The predictions agree with measurements. That is what we mean when we say quarks exist. We mean that the predictions obtained with the hypothesis agree with observations.
Okay, so you see what's real to them is calculations that describe observations. Now you see these calculations are based on the standard model. So let's go to Wikipedia. Let's read this definition with this new understanding that we just garnered from her explanation.
The standard model of particle physics is the theory describing three of the four known fundamental forces, the electromagnetic, weak, and strong interactions, and not including the gravitational force, in the universe, as well as classifying all known elementary particles.
Okay, so you understand the standard model is where we get the periodic table from. That's where you get the image of the proton in the middle, the neutron in the middle, and the electrons going around it. All right, so this is what the standard model is, and it's focused on the three of the so-called known forces, which is the electromagnetic force, the so-called strong interaction, and the so-called weak interaction. But we're gonna go into those in a minute, so let's keep reading.
It was developed in stages throughout the latter half of the 20th century through the work of many scientists around the world, with the current formulation being finalized in the mid-1970s upon experimental confirmation of the existence of quarks.
So you heard that? The standard model was finalized in the 1970s with the experimental confirmation of the existence of quarks. But she just told you what the quarks were. An equation, you see? So everything is based off equations of math that are descriptions of observations.
Since then, confirmation of the top quark 1995, the tau neutrino 2000, and the Higgs boson.
The Higgs boson and quarks are names that we have given to mathematical structures.
2012 have added further credence to the Standard Model.
Make no sense, yeah, it make no sense, no, it make no sense, yeah, make no sense.
Although the Standard Model is believed to be theoretically self-consistent and has demonstrated huge successes in providing experimental predictions.
Okay, so you see, the Standard Model is theoretically self-consistent. This is what I mean when I say World of Warcrafts. Within itself, it works. But when applied to the real world, it makes no sense. It's not realistic, you see. Now watch, when they try to apply this Standard Model to other aspects of reality, it doesn't fit. See?
It leaves some phenomena unexplained and falls short of being a complete theory of fundamental interactions. It does not fully explain baryon asymmetry, incorporate the full theory of gravitation as described by general relativity, or account for the accelerating expansion of the universe as possibly described by dark energy. The model does not contain any viable dark matter particle that possesses all of the required properties deduced from observational cosmology.
Alright, so let's go back here. Now you see what the Standard Model is. You see what's real to them. Okay, you see what exists. Alright. And now let's go back and try to get a better understanding of where they're coming from, and why I will once again say I will put forth a clean glass of water as opposed to just condemning the dirty glass in which has been forced down our throats. So what stops the positive charge protons in the middle of the atoms from springing apart? This is where, within the Standard Model, the strong force comes about. The strong interaction. Okay, it's the strong nuclear force, because it is supposed to keep the protons from springing apart. Okay, so we're gonna go to this video, and I'm gonna let this other physicist explain to you the strong force, and just watch how he talks about this as if this is 100% correct, it's 100% fact, as if they've seen this with their own two eyes. But we know that these things are nothing but calculations that fit within theories. Alright, so we're gonna just use their explanation, and then we're gonna critique it. So let's see what he says.
If you're interested in learning about particle physics, one of the key topics you need to understand are the forces that come into play. For instance, we know of 4 fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Of these 4, we have at least a little familiarity with gravity and electromagnetism, so naturally, I want to tell you something about the strong nuclear force. The first question you might want to know the answer to is, how do we know that there's a strong nuclear force at all? Well, this is something we've known for essentially a century.
Notice how he says this is something we've known for 100 years, but we know these things are nothing but mathematical equations that are used to describe observations. But you see how he says, we know these things, we know this. Now watch how they know this, Pete.
In 1911, Ernest Rutherford discovered the basic structure of the atom, which is that it consists of a small and dense core of positive electric charge called the nucleus, surrounded by a cloud of negatively charged electrons. And in 1917, he discovered the proton, which meant that the nucleus consisted not of a big blob of electric charge, but of a whole bunch of smaller blobs held together. Remember that each proton can be imagined as a tiny ball with a positive electrical charge. They say that opposites attract, and that might well work for couples, but it's definitely true for electrically charged particles. On the other hand, like charges repel each other. So let's imagine a simple nucleus consisting of just 2 protons. Since each proton has a positive electrical charge, they push each other apart. And they don't push each other apart a little bit. The repulsion force is about 20 pounds. 20 pounds is a respectable force in the world of you and me. In the particle world, it's huge. It's so big that if you let the two protons go, they'd push until they were moving away from one another at a speed of over 8,000 miles per second.
All right, now I really need you to absorb what he said. You understand? He said the protons, the force between two protons is so strong that without the strong force acting upon it, they would spring apart at 8,000 miles per second. Okay, so that's how strong it is, up to 20 pounds for something that small. You know, if you do the comparative math, that would be like a human being. You know what I'm saying? I don't know, like a Superman, essentially, be able to pick up a big building. You know, for something that small to be able to lift 20 pounds. You understand? If you do the ratio math, what have you. So keep that in mind when we do our mental experiment later with their own philosophy. Okay.
And I just picked the simple case of two protons. In the case of uranium, there are 92 protons all packed together in a ridiculously tiny volume, and a proton on the surface is repelled with a force of just over 70 pounds. So, if these protons are all getting pushed apart from one another, what keeps them together? There's only one possibility. There has to be a force that is even stronger that counteracts the electromagnetic repulsion. And the name for that force is, you got it, the strong force.
Okay, so the only reason that the strong force exists is because it has to exist, because that's the only way they can explain their atom structure the way it's structured. Now, the book Future Science presents a different structure for the atom that still fits within the experiments of the standard model, but makes more sense in the practical world. And it doesn't require what we call gravity. So that's what we're gonna go into the Future Science book in future videos. And then I'm gonna show that how that relates to what we know as astrology. But for right now, I'm gonna let him finish explaining what this is, and then I'm gonna show you just what a mental exercise you can do for yourself, why it doesn't make any sense.
What do we know about the strong force? Well, we know that it's strong, and it can't just be a little stronger than the electromagnetic force. That's because if the two forces were pretty similar, it would be easy to knock protons out of the nucleus of atoms. And we know that's not true because nuclei last for millions and even billions of years. So the strong force has to be way stronger. From tests, we know that the strong force is about 100 times stronger than the electromagnetic force. But the story is a bit trickier than that. After all, if the force is so high, what keeps the strong force from continuing to gather protons until the whole universe consists of one big nucleus? If we look at the periodic table, we see that the highest stable element has no more than about 100 protons in it. And yes, I know that the nuclei also contains neutrons. That doesn't change much in what we're talking about here. So it seems that with more than about 100 protons, the strong force can't hold it all together. What's that all about? It turns out that there is a property of the strong force that is quite different than the electromagnetic force. Electromagnetism has an infinite range. In principle, two electrically charged particles will feel a force between them if they're separated by the entire universe. Okay, the force would be small, but in principle, it's true.
All right, keep that in mind, that the electromagnetic force is so strong that two particles on the opposite sides of the universe can still feel the energy from each other. Even though it'll be that small, they still feel each other. So that's how strong the electromagnetic force is. Okay, keep this in mind.
In contrast, the strong force is more like a contact force. When two protons touch each other, they feel the strong force. Pull them apart a little bit, and the strong force goes to zero. In a way, the strong force is a little like Velcro. When two pieces of Velcro aren't touching, the two pieces feel no force toward one another. So that's the strong force. It is stronger than the electromagnetic force, but it has a much shorter range. And those two properties explain why low-mass nuclei are stable and heavy ones aren't.
Okay, so you see what their logic is for the strong force. But I'm gonna show you why it makes no sense even in itself. Because the premise is that everything came into existence from a Big Bang. Right? So that's an explosion, correct? All right. So when that happened, everything expanded, right? So at what point did these particles get close enough to each other for the strong force to overpower the electromagnetic force? No, how did helium get created? Okay, because the hydrogen atoms that would have been created essentially from the Big Bang would forever be hydrogen atoms. At what point would they have become helium atoms if the electromagnetic force is so strong and two positively charged protons can't get that close to each other? How could they have possibly gotten close to each other to create the helium atom in itself? At what point? It had to have been a point when one particle combined with another. What force made that happen? They'll claim gravity, but we know gravity ain't nothing but an equation. It makes no sense. You see? So their strong force and standard model doesn't even make sense in itself. How did the atoms come? How did the two protons come to be within the proximity to which the strong force could take effect when the electromagnetic force is stronger and wider, right? And wasn't it the electromagnetic force that was created at the Big Bang, right? So this force would continuously be spreading atoms apart. How did they come together? And we know that gravity is weaker than strong force, magnetism, and the so-called weak force. And let me just show you how funny it is about this weak force nonsense. All of this is nonsense, people. The only thing in existence is the energy, and that's what we call electromagnetism. Okay? That's what it is. All this other stuff they talking about, they made this all based on theory. Okay? So, the so-called weak force, right? They are now proposing an electroweak interaction. Peep this. In particle physics, the electroweak interaction or electroweak force is the unified description of two of the four known, remember what was known and what exists, fundamental interactions of nature, the electromagnetism and the weak interaction. See, remember the standard model got the four main interactions. Electromagnetic, the weak and the strong, and then the gravitational, which we know gravity is a math problem, right? Then we know the strong interaction don't make no sense because how did it come about? Okay, and then the weak interaction, which is basically their way of describing entropy. They even acknowledging that is a unified force with electromagnetism. See, although these two forces appear very different in everyday low energies, the theory models them as two different aspects of the same force. And that same force is electromagnetic. That's why they call it electroweak, you see? So they're admitting essentially coming to the realization, or they have no choice because they wasting their time with smashing these protons and neutrons together, creating these temporary hadrons. The hadron collider. Anyway, not to get into that for right now, but to keep it simple, they have to go back to the ancient ways and the ancient teachings, because that is what's lasting through all this fake crap they've been spewing since after the Civil War and Reconstruction. Period. So, just to finish this one out, You know, it's the ancient teachings that we need to be focused on. And I'm going to keep going. This part 2, just to show you that the standard model makes no sense. And even by their own logic, it really makes no sense. And we need to be looking at a different way to view life. We can't be listening to these people that the TV tell us are so-called geniuses of our so-called society. So, you see this ancient statue in America. When nobody in our Negro black history coming to us with the same poses and same attire as our ancient statues. Nobody before him. Nobody did it like him. Alright? So, peace and love, man. Y'all focus on this science. Take it.
Same story for time. In general relativity, time is a coordinate, much like space. It is part of the mathematical framework. We use it to make predictions. The predictions agree with observations, and that's that. Now, you may complain that this is not what you mean by existence. You may insist that you want to know whether it is real or true. Now, I do not know what it means for something to be real or true. For that, you will have to consult the philosopher, and they will offer you a variety of options that you may or may not find plausible.